Hello YouTube, RJ. Hey, I thought a lot about this meter after we got it apart, and I went ahead and screwed the meter back on the faceplate to protect it after we've got it so nice and everything. And I went ahead and started checking resistors. Obviously the capacitors are going to be changed, but on the resistors, some of these carbon composites on the board, you can't really see, but some of these composites on the board here are just surprisingly far out. Let me get my sheet over here so I can can look at a few of them. For example, just to give you an example how bad it is, let's see if hopefully this will show up good. There's a 3.3 meg right here. Every range you use ends up going into that before it goes in the grid of the tube. And so this voltage, what actually does the measurements by controlling this grid, we change the current between the two tubes and therefore offset our bridge, and we generate a differential in the meter down here. So when you make a selection of a range, you choose the resistors, and I'm going to do a follow-up video where I walk you through this circuit and explain how it works, because it is kind of an interesting circuit, and it worked very well. Every range is going to be reliant on this resistor, and it's a 3.3 mega ohm resistor. Mine's reading 3.78 megs. I've checked it on multiple meters. It's about 14 to 15% off. Just imagine for a moment that if every resistor in here was correct, everything was perfect, your meter could be no more accurate than that. Yeah, you could try to calibrate it, but remember, if you calibrate full scale, you're only getting it perfect there. Your error builds up as you go down. You're not calibrating it across the scale. You're just getting as close at the most at the top of the scale you can. So it's as accurate as it can be at the top of the scale, and the farther down the scale you go, the less accurate it will be. You're not really fixing that problem. This is unacceptable. So obviously, well, when I started looking at other resistors, I was finding 2.2. Now these are these precision resistors on the range selection shift switch. 2.2% out, 2.9% out. Some of them were really bad. Some weren't bad. Here's a 0.15%, a 0.25, a 0.32. These were 1%. I consider those to be okay. But 0.79 is getting up towards 1. 0.96 is basically your 1% tolerance already. 2.9 is out. 2.2 is out. So what I'm going to do is I made the decision that I'm going to do the very best I can at making this meter better than it was when it was new. Now that may seem ridiculous, that can't do it or no reason to do it. But my thinking is this: if I've got to change a couple resistors, go ahead and change any that are even slightly off. Get this meter as close as you can. So what I did is I went ahead and I just ordered resistors for this thing. I'm going to replace the capacitors. I'm going to replace the resistors. When we're done, we're going to be using modern resistors that won't drift as much, that have better temperature coefficients. I'm hoping to make this meter more accurate than it was when it was new. Now, if I'm going to do that, bearing in mind these meters aren't of value. They're not something, oh, keep it original, it's worth lots of money, RJ. They're not. You can buy, I bought this one for $24. My idea is take this meter and see what I can do to make it the best meter for me that I can. Because of that, because I'm going to do these things, okay? Therefore, why not go ahead and make it look the very best I can? You might have already figured out what's going on over here. I've stripped the case down to bare metal. And you know that I had that where they damaged it with a screwdriver and caused a crack and dented in. If you can see here, I have, using a hammer and a little work here, I have brought that up and fixed it. And what I've done is take a little bit of JB Weld and filled the little crack up and the little bit of low spot. And I'm going to let this harden overnight, and I'm going to sand it down. I'm going to repaint this. Now, what am I going to repaint it? I want it to look original as much as possible. Hard to get Heathkit colors. They didn't even use the same colors as the years went on. You'd find this meter, and if you compared them, they were different colors. And you know that's a fact. That's not a guess. That's infamous. You can go read online all about how two Heathkit exact meters that were basically the same color scheme, but 2 years apart, had different shades of colors. But what I did was I didn't want to spend $50 on custom paint to match the color considering the color that was on here wasn't the color original anyway. We all know in all these years this thing's faded and changed color. But what I did do is I went and started looking for just regular spray paint, and call it luck, call it whatever. But if you remember what it looks like, this color is as close to dead on my meter as you could find. This is granite. It's Rust-Oleum Painter's Touch 2X Ultra Cover Paint and Primer. I think it's going to be almost spot on. Now, here's the problem. It's not textured. But I did find this texture that, looking at what it turns out to be, is wrong color, obviously, but it's very close, not perfect, but very close to the texture this case was. So I'm going to go ahead and, what I'm going to do is I'm going to put a little primer down, put a little texture, just light coated texture, black on, let them set up good, and I'm going to come back and I'm going to paint it with this color. And I think we're going to have a case that looks so much like it did when I got it, just cleaner and brighter. It cleaned up good in ultrasonic cleaner, but it still was stains. There was some stains that aren't going to come out. There was paint missing and chips here and there, spots of shiny metal. So this will make the back of the case look so much better. Now, you might say, RJ, what about the front of the case? Well, I thought about that, and there is some chipped paint you can see up here. The problem with repainting this is I would be willing to do it, but the text, I even thought, you know what I'm going to do is I'm going to take a photo, take the meter back off and take a photo, bring it into Photoshop and Paint Shop in my case, get rid of everything but the text, invert it to black and make a silk screen, make an exact silk screen of this text and repaint this, get a matched color, find a color that matched. It's not exactly, it's a darker color than that, and silk screen this back. The problem is when I really got to looking, if it was all this size text, I can tell you I'd be able to silk screen it no problem. The problem is some of this smaller text is going to be an issue. The silk screen that I use to silk screen is not like the big commercial companies use. They have a high definition version that I use that does really good. You can get some pretty fine stuff, but when you get down this fine, it's really hard to get good print. I just don't think I could get these small prints to come out, and I don't want to change the text much larger and to make it look funny. I thought about that. I'm still thinking about that. I might do that, but probably we're going to have to live with the little chips and such. I don't think I can get a close enough match of paint to touch this up that it wouldn't stand out like a sore thumb, but I may break down and just scale these up large enough and silk screen this and repaint this and make it look like a new meter. When the resistors and everything comes in on the Mauser order, we'll get back to this meter. We'll start replacing these parts. I found a solder joint on the volt DC adjustment pot that was literally not soldered. I think that was part of what was going on with this meter. It makes a lot of sense. So I fixed that so I wouldn't forget it, but I'm going to replace these parts, and anything I don't replace, I'm going to touch up the solder joints on to make sure we're good, and then we're going to go from there and see how this thing comes out. Hopefully I'm going to end up with a very accurate, good old vacuum tube voltmeter. So stay tuned. Let's find out how good we can make one of these meters. Okay, just a little montage to show that I did decide to go ahead and do the front panel. So I'm in Paint Shop. I'm getting all the markings. I've took an image of the panel and I'm in here editing and cleaning it up and getting it ready to make a stencil out of it for stenciling the text back on the front plate. So I found a paint that is a close match. I might as well make this thing look as new as possible. So a lot of time put in on this. Little side story, I did all this work and then ended up using it as a template to go and put new text. I was able to find a font that matched what Heathkit had used. I turned around and just created new text to give me a clearer, cleaner text for a better stencil. And then just lined it up with the text here, sized it and lined it up with it to make sure the spacing was accurate. We've got it up here. My parts have come in from Mauser. We're ready to start replacing parts. We've got the fume extractor set up here, so hopefully we won't have to breathe so much fumes. I've got my most accurate resistance ohm meter is, of course, my LCR. So I've got it set up and calibrated so we can check resistors for the best ones for the value that we're supposed to be replacing. So let's get started. I've got this capacitor out here, the electrolytic for the power supply filtering, and I'm going to go ahead and get that swapped out. And this, this will take a little time to get this whole project done. So when you see these jump cuts, it's because I'm just editing down time. There's no reason to make you watch every step all the way through. So I've kind of jumped through so you can see what I'm doing without having to watch it minute by minute. Also, I'll highlight the things I think are interesting or important and kind of breeze through the things that aren't. Okay, guess I'm gonna get this nasty old film capacitor out of there. I just gotta find it. So this is a 0.01. There. I couldn't get a couldn't find a 1600 volt to match it, so I got a 3 kilovolt. So shouldn't blow that one up due to voltage. Now, normally I don't solder straight at the switches on old equipment. This equipment's not that old and not more modern solder and stuff, so I'm not going to be worried about it on this one. I'm going to go ahead and just remove it right at the connection. I'm going to use the heat shrink on it that was on it. And I will go ahead and throw a little solder on this, tin it a little bit. That way I don't have to do a lot of extra work to get it in there. Okay. Hopefully you can see. Try to get set up a little better with this camera and see what it's doing a little better. Make sure you're in focus. There. Let's adjust this rascal just a little bit. Okay, how about that? All right. So this one goes right here. I'm going to do the same thing I did with that one. I'm going to cut it off right at the terminal on the switch. I'm sorry. Sometimes I start to say something and stop while I'm thinking. Good. So our filter capacitor changed out, and that blocking capacitor changed out. So that's two biggies that had to get changed. Okay, now let's take a look at what we want to do here. First of all, we had a bunch of resistors to change. Now this 3.3 that was reading so far out, why don't we go ahead and get him done. Bent lead, bent all the way over tight. I know why people do it, but servicing makes servicing so much harder later. To pinned up a little bit where I can get the solder sucker on there better. You can bend up then. There we go. You can see that. Let's see what we can do over here. Same problem. Come on, get him up. All right, let's see if we got him out of there. Yep. All right, let's make sure out of circuit I'm not crazy that was reading way high on resistance. Geez, it was worse than I thought. It was getting a little bit of an effect from being in circuit. 4.121 mega ohms. Yeah, that resistor is a little out. Let's see what this 3.3 measures. And if you remember from me, well, if you remember from me explaining that 3.3 is in line with all of your voltage readings, so everything would be out. There would be that error would affect everything. Look at that, 3.2993. How much better can you get than that? Wow, that should help. Let's get him changed out. Now you're going to notice this resistor is a lot smaller. Don't worry about it. It's okay because modern resistors are much smaller for okay. Let's get him soldered back in. You want to watch how long you're on these old pads of these old circuit boards. They're not like modern boards. They don't like heat. They don't hold up as well. So just remember when you're working with them, try to limit how long you're on with the soldering iron. So one tip is don't run your soldering irons too low. Keep them turned up reasonable. Don't go ridiculous. But, don't run them at the bottom of what you think you need. The idea of soldering iron is not, oh, I got it at the temperature, it'll melt solder. That means you're going to be on there forever. You want to be much warmer than that so that it will bring the temperature of what your joint you're working on up much quicker. And that's that way you can get off of it. It's not just temperatures, it's times. These traces can handle a higher temperature as long as it's short. The lower temperature will melt it right off of there if you stay on it. So just keep that in mind working on these old circuit boards. These were kind of early circuit board in the, they hadn't quite perfected the technology. Or let's put it this way, I won't say they hadn't perfected it, they just didn't have the quality technology. They hadn't figured out better ones. Now, what I'm going to do is I'm going to reach over here and grab the schematic with all the different resistors to help me out. I'm also going to grab the manual that has the layout of what's what to help me out. And I'll put these over here, and that's my visual guides. And that'll be helpful to know. Sorry about bumping the camera. That'll be helpful to know what I'm changing out. And with that, we'll end here, and we'll continue in episode 4. Hope to see you in the next video.